Oh, good morning, class. Hope everyone is well. Let's get started for today. So today we'll be learning about the derivative and the tangent line, stuff like that. So, talk about slope. First off, everything we do in this class from here on out, well, until like December, is going to be like slope. Everything has to do with slope. Rate of change. It's a huge deal for calculus. So let's talk about how you found rate of change back in like 8th grade. So in a problem like this, what's the rate of change on this problem? 2. How'd you know that? Right? It's the coefficient in front. This is in mx plus b form. So this line starts up at 3 and it has a slope of 2. Right? So the slope here is 2. Does the slope ever change? The slope is the same every single spot that I would put this. Can we even see this at all, or should I turn this little light off? Is that better? Jonah, can you hit the lights, turn them off? I think if the lights come off, it's better. I've never done notes on purple, so. It got worse? Okay, alright. This is better? Is that better? Okay, I'll do all the notes in black ink. I hope I don't make a mistake. Well, I am perfect, so that won't happen. Not at all. Okay. So this slope is constant. So this is a constant slope. What shape is this guy right here? It's a parabola. Alright. It got shifted up too. It's a parabola. Is this slope constant? It changes. So at like this point right here, that's like a slope of like 1. Right? If I come up here, that's like a slope of maybe like 2. So the slope is changing. So this one has a variable slope. So the slope at every single point in a parabola is different. There's no constant slope whatsoever. All right? Does that make sense? That's all we're doing. So we're just trying to determine. That's what calculus is for the most part. Is you're trying to find the slope at certain points of certain functions. Some functions are super easy and simple. Like this one's actually pretty simple. There's some functions that are like super difficult. And there's little shortcuts to how to do everything. So let's talk about how to kind of predict the slope. So if I need to find the slope of a line, like in this lovely picture right here, maybe blue will work better. So if I wanted to find the slope right there, where they start going down, I don't know if that's the downhill or the uphill part. If I want to find that slope, the easiest thing to do is to find 2 points on here, and then find the secant. What's the secant? Very good, and not the trig secant. What's like a secant of a circle? What's a secant of a circle? It's when it goes through the circle, right? At 2 different points. It's the same thing here. So when I say the word secant, it just crosses in 2 places. So that's what the secant is. So if I ever use the word tangent, what does tangent mean? It touches 1 time. This is not trig, this is geometry. So the secant, that's an estimate. That's an average rate of change. Did I say A rock? Average rate of change. Somebody got really lazy there. In tangent, that is the instantaneous. That is the exact. All right, so that's the rate of change, like exactly at that one spot. Okay, so that's what we're really talking about. So how the heck in the world can we estimate a rate of change? There is a way that we can use the secant to find the exact value of the rate of change. Are you ready for the lovely picture I'm going to draw you? I'll draw it right here, and then it'll make sense on the next page. Okay, so let's say I have this parabola right here, the one that we started with, the x squared plus 2x. And I wanted to find the tangent at this spot right here. Well, didn't we just talk about how to find the tangent? Well, we can estimate it. So how can we estimate this? Can you find the rate of change of those two blue points? So what is the rate of change of those two blue points? So let's say that this is, I don't know, x1, y1, and this is x2, y2. How would you find the slope of that? Yeah, you've seen this before. So let's zoom in. Let's pretend we have a calculator. We're going to zoom in. So I'm zooming in a lot. So now I'm going to take this little part right here. I'm going to zoom in so it looks like this now. Alright, so I zoomed in. Do you agree to get more accurate, I should get even closer to this? So I should have my blue points even closer. Do you agree? That's more accurate. I'm going to keep zooming in, so I'm going to zoom in again. I should zoom in until what? Literally, these blue points are literally on top of it. Okay? I'm going to keep zooming in. So what I want to do is I want to keep zooming in until the limit is 0, until the distance between the 2 points is 0. So this is where the limit stuff comes in. I want to zoom in to the point where there is no distance between my blue points. Okay? So essentially, what's going to end up happening here, I'm going to zoom in so much that one spot is actually on that spot right there. That's blue-black, and then the spot is right next to it. Okay? So then this literally right here, this rise over run, is like so tiny. Okay, which brings me to this formula I'm going to be showing you right here. Is this one right here. So this is the definition of a derivative. This finds slope. Finds the exact slope, I'll say. So again, the top part is the difference in my y's. It's that y2 minus y1. So this really is like y2 minus y1. Alright, and my x's, I only have one x because I made it so close that there's only just one x spot. So this h is really the two x's being subtracted. But I'm taking that h and I'm making it go to 0. So this is going to find me my exact slope at that point. Alright? So the derivative, again, is the slope generator. We want to find the derivative to find the exact slope. Let's go a little bit of notation now. So the notation, f prime, have you ever see that? It says f prime of x. That means slope. That means rate of change. Those are the exact same things. Rate of change, slope, differentiation, that's the big calculus word we'd use. That means slope too. So the notations. So here's notations for a derivative, by the way. So if we're talking about slope, we can mean f prime of x. dy over dx. So we would use dy over dx if we ever had like a y equals equation. D over dx, that's just if we have like a time equation and we want to take the derivative of time. You can also do y prime. These are just different ways. that you can see it. So if you're like, oh my gosh, what the heck does y prime mean? Well, it means derivative. And you'll see it so much that you'll just get used to it. Okay? So let's take a look at this first example right here. Let's find the derivative using the limit of the definition of 2x squared minus 3. Okay? And then we'll kind of go from there. So let's do part A. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So what we need to do now is, the first part's really where all the work comes in, really where the thinking comes in, is you have to know what x plus h is. So take our function and replace x with x plus h. So what does that become then? 2, not x squared, but x plus h squared minus 3. I'll color code this a little bit. So this red right here came to be that red right there. Okay. Minus, what is f of x? Just 2x squared minus 3. And I'll do that one in blue. So that really came from that right there. All over h. So how many substitutions did I do? Just 2. The calculus is now over. Let the algebra begin. From here on out, it's really just algebra and simplifying. You cannot plug in a 0 right away for all of these. What happens if you plug in a 0 right away? Very good, class. You get 0 over 0. That's fantastic. Plug in a 0 on the top, you're going to get 2x squared minus 3 minus 2x squared minus 3, which is 0. All over, we plugged in a 0 for h, 0. So you have to do some algebra. You have to get rid of that h. That's the whole game, is get rid of that h on the bottom. Once that h on the bottom goes away, boom, plug in 0, bam, answer. Okay? So let's go ahead and do that. Let's simplify this a little bit. So what is x plus h squared? Very good, class. It is x squared plus 2xh plus h squared minus 3 minus 2x squared. Why am I writing a plus 3 right there? Because I just should be the negative. All over h. So now we're going to get 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3. And things start to cancel out. What cancels out? 2x squared. Bam! Bam! What else? Bam! Bam! Anything else? Not at the moment, but it will in a second here. So we're going to get the limit as h approaches 0 of 4xh plus 2h squared all over h. Can I cancel that h on the bottom yet? I'm just about there, because the top has a GCF of what? 2h. You could do 2h or you do h, because all you're trying to do is get rid of that h at the bottom. I don't care. Do you want to do 2h or h as your GCF? You're all very opinionated, and I appreciate it. That's what I'm doing, is I'm factoring it, essentially. Taking out a GCF. Like, you could take out a 2h and then cancel out the h's and everything. That'll work. I'm just accustomed to always taking out an h. I like just taking out an h because I know it's going to cancel out. So it becomes 4x plus 2h. And then what happens? These h's cancel out. And I'm left with 4x plus 2h. So when I plug in a 0, what do I get? Get 4x. So this is, right here, that's f prime is 4x. What that means is that's the new function that can determine my slope. I can use that function to find the slope at any point I want. So, like, for instance, at like x equals 2, what's the slope at x equals 2? Well, I just plug in a 2 here, and the slope at x equals 2 is 8. What's the slope at 0? Plug in a 0, and I get 0. Yes? Right, so essentially, this function right here, if I were just to draw that real quick, that would just be like this guy. So now I know this is the derivative function. So like at x equals 2, the slope is 8. So I know that that line I'm drawing is 8. And at 0, well, doesn't that make sense that at 0, the slope is 0? So x equals 0, the slope is 0. Isn't this so fun? You can find the slope of every point on this parabola. Whew, that was so fun. Okay. What about the slope at this point right here? Let's actually answer question B now. So question B, what's the slope at 1, negative 1? So, well, so what's f prime at 1? Not all at once, everybody. 4. So the slope is 4. I'm just writing m equals because that's what you're used to seeing. Like, I'll stop doing m equals as soon as this lesson's over, because I'll always use this notation for slope. Now, so I'll draw this. Here's the red on this graph. So that's, pretend that's 4. That slope is 4. Now, part C wants me to find what's the equation of that red line I just drew. So how can we find the equation of the red line? Isn't there like some type of formula that might have, like, you know, like where you're given a point and a slope? Oh, the point slope formula? Oh, okay. Anybody remember what the point slope formula is? If you don't know it, by the way, I wrote it right here. Isn't this point slope formula, if we just multiply the denominator over here, doesn't that become the point slope formula? We literally just take the slope formula that you memorized, and we're just manipulating it. So the point slope formula is y minus y1 equals m x minus x1. Okay? Or y minus y1 equals f prime of x minus x1. I don't care what notation you use, but sometimes people for easier to remember, like, oh, the slope is f prime. I don't really care. So let's plug in all of our values. So, y minus, what's my y1? It's right up here. That was nice of them to give it to us, by the way. That was so nice. If they didn't give us the y value, what would we do? Plug it into the original? Plug it into the original? So this is y minus, well, plus 1 equals, what was my slope? 4x minus 1. And you're done. Welcome to calculus. This is correct. No simplifying required. If this is multiple choice, you might need to find out which multiple choice one it matches with. But if this was a free response, full credit. I've seen people put this, and then they go to find for y equals, make a tiny boo-boo. No credit. Sorry. What were you doing simplifying? So just leave it like this. Perfectly good answer. So we can now find the slope, the equation of a line at a certain point on a graph. All right. There are different forms, by the way. There's different forms of this. This one looks a little more familiar. This one looks a little bit more like the slope form that we just did. We do the y2 minus y1 over x2 minus x1. This one looks like this one. So let's go through the same question. Find the slope of f of x equals x squared plus 3 at the point 2, 7. Again, if they did not give us the 7, how could we find it out? Plug in a 2. They're so nice. They're so nice. Using the alternate form of a derivative. Then write the equation of the tangent line at that point. So we're going to go through and do the same process here. We're going to use this function, though, right here. Okay? So now, to find f prime of 2, my a values turn into what? 2's. So I'm going to find the limit is x approaches 2 of f of x minus f of 2 all over x minus 2. Well, what is f of x? X squared plus 3. What is f of 2? Hey, let's do a little bit of side work. What is f of 2? Oh, I didn't really do side work, did I? It told me it was 7. That was nice. All over x minus 2. Doesn't this look like a problem we've done before now at this point? If I gave you this question in your test, you should be able to figure it out. So what do? X squared minus 4 over x minus 2. How does x minus 4 simplify? Because I can't plug in a 2. What happens when I plug in a 2? You get 0 over 0. That's not cool. So this becomes x minus 2, x plus 2. So what happens now? Cancels out, and we're left with the limit as x approaches 2 of x plus 2, which is equal to 4. So our slope is equal to 4. It says write the equation of a tangent line at that point. So all I do is I literally just plug everything in. So y minus y1, which is 7, equals slope, which is 4, x minus 2, and call it a day. Alright. Now this second alternate form, I don't ever really use that one because it's exactly the same thing as the one before. It's the page before. It's the same thing as that one. The only difference is instead of finding the derivative function, you're just trying to find it at an exact point. So I'm not too worried about it. Can we just move on? We've already did a problem like this. Are we good with moving on? Okay. Alright, so let's do all these problems. There wasn't a lot of groaning. Alright, let's do all of these problems. No. You're supposed to groan. We have to do all these problems now. The males know how to groan. They're groaners. Females are polite. They're like, I don't want to groan, but I really want to. Luckily, we actually don't need to solve all of these. Because very soon, as soon as next class, you're going to find a shortcut in how to do all this. See all this work we did here? There's a one-step shortcut. Boom. Find the answer immediately. So pretty soon, we're not going to do the limits anymore. So the limits are now phasing themselves into the background for the rest of calculus. They're starting to go away. Okay? What you need to do, though, is you need to be able to recognize, using this, what is the function and where are they trying to find the slope at. Okay? Or for some of these, yeah, that's it. You're just trying to find what the function is, and you're trying to find, that's really it. It's just for these, you're trying to find the function. Some of them you can figure out what they're trying to find the slope at, and I'll point that out for you. A lot of the multiple choice questions for this, because these are shortcut, because you have shortcuts to do these, they'll like never ask you to do this by hand. So what we just did by hand, they'll never ask you to do that by hand. They'll ask you how to do the shortcut, though. So let's talk about how to do the shortcut. So let's look at this first guy right here. I'm going to ask you two questions, or I'm going to give you a question with two choices. Is this the definition of the derivative, or is it the alternate form? So the alternate form is the one where it was like y2 minus y1 over x2 minus x1. Definition of the derivative just had the h on the bottom by itself. So it's not that hard to figure out which one's which. So letter A, is this the original form or the alternate form? It's the original. Where's the function located on the original? Right there, correct? Alright, because it's f of x plus h minus the original function. So what is the function? And that's all I care about right now. Because down the road, they're going to ask you to find this limit. And you can go through all the work. This one's actually not that bad. Or you can recognize, oh my gosh, that's a function, shortcut. The answer is 1. That's super easy. I'll let you figure out the shortcut on your own, by the way. I'll tell it to you next class. Or maybe I'll just get so giddy I'll do it today. I don't know.
I think you should figure it out. They tell us.
How long do you want to be here? Alright, letter B. Is this the original form or the alternate form? Where's the function located on the alternate form? It's in the front. So what's the function? So which one's the function? If you said it was in the front, which one's the function? I'll kind of hint at this. So that derivative is 1. You don't know how to do that yet? Let's see if you're going to figure it out, though. This derivative, anybody think they know what it is? (6x minus 2). You'll start to notice a pattern soon, I think. I'll just keep doing these for you until you're like, oh my gosh, it's right there in front of my face the entire time. Did anybody figure it out yet, just from me just saying that? What do you think it is?
Oh, it's,
Do you know what it is, or you're...
I know what it is.
So you're not guessing, you know exactly what it is.
I think.
Oh, okay, so you are kind of guessing.
See, that's what I'm saying. So, what's multiplying x is what it is, right?
Let's go to the third one. This is what I'll do. We're going to the third one, and I'm going to ask what the derivative is, and then if you can figure it out, great. So for this one, is this the original form or the alternate form? Original. So where's the function located? In the back. What's the function? All right. What do you think the derivative is? Nope. You're kind of close. Just keep guessing numbers. 4x minus 3. All right, we'll have him do the next one then. So for D, what's the function at D? Ooh, this one's a little different. Okay, this function's a little bit different. Is this the original form or the alternate form? It's the original form, so where's the function? The function's in the back. But where's the x really located? Compare these two right here. Didn't they plug in a 4 instead of x? So what's the original function? Right? So all they did was replace that 4 with the x. That's all they did. Same thing up here. That one's a little bit trickier. So technically for this one, what is f of 4? It'd be 18. Someone let Neil in.
We ask him to find the derivative.
No, I don't want to be here forever. How'd it go? We'll find out. You might want to prop that door open with the, yeah. No, you just had your hand on it. Move it to the other side. There you go. Okay, so the function. Jason, you think you have it? It's 2 what? It's just 2x. So in this case, they plug in a 4. What's f prime of 4? 8. It's not that hard. We're not doing rocket science here. All right. What about this one right here? Letter E. Which form is this one? I'm just trying to find the original. You can't find the derivative of this one, and you'll never get it. I mean, like, by you'll never get it, you'll get it, like, in 3 weeks. But you won't get it for right now. So what's the original? So first off, which form is this one in? It's actually alternate, because see how we're going to 0 here?
Oh, it has to be. Oh.
So what's the function? Cosine 2x. I'm not even showing you the derivative, because it's not worth it. Letter F. What's that function? Anybody think they know what the derivative is? Who said that? Did you figure out how to do it now? How'd you do it?
Oh.
No. What is the reason? There's a reason most of them are double. Well, let me just tell you. You want to know? Because the last 2 examples, you can't do it. Okay, all you do, for any polynomial, take the derivative. You take whatever the power is, you multiply it in front, subtract by 1. So take this power, so it becomes a 6. 2 minus 1 is 1, so it's 6x. Take the next one. The power is a 1, so 2 times 1 is 2. Subtract 1 from the power, you'd get 0. X to the 0 is 1. So it's just 2 times 1. That's the rule. So take the exponent, multiply it in front, and then you take away 1 from the exponent. And you do that to each term. Oh, that's squared. Oh, that's cubed? Oh my gosh. So this should be a 6x squared. Sorry, I didn't know that was cubed. But anyway, we'll talk more about that next class. So now when I teach you next class, you'll, yeah, that's easy. We got it now. Alright. So now these last two, they're not polynomials, so I'm not going to find the derivative of these guys. So let's just find what the original function is. What's the original function? ln of, it's not x plus h, it should just be ln of x. So all we're doing is we're actually finding it at 4. And then for h, which is my original function, do we agree it's a square root? Do we agree they plug a number in for x? Yeah. Okay, so what number do they plug in? A 3, right? So it should be x plus h minus x plus h squared minus x plus h. So what's the original x without the h? X squared minus x. If you're not getting it immediately, it's just because you need more practice. It's fine. So this right here is finding the slope of f of x at what number did we say? X equals 3. That's all it's doing. So how would you do this problem from last unit? Let's just talk about it and then we'll move on. How would you do this problem? Multiply by the conjugate. Simplify. But don't worry, you never have to do that ever again because of the shortcut you will eventually learn in the near future. All you need to do is look at this, recognize what the function is, and then I'm going to teach you how to take this derivative. It goes much faster. Because again, these questions you're going to be taking, they average 2 minutes at multiple choice. This is going to take longer than 2 minutes to multiply by the conjugate. If you know the shortcut and everything, it takes about 1 minute. So that's why that's kind of why we're going through this little exercise. Recognize the function inside of it. All right, going on a completely different idea here is differentiability and continuity. So we already know about what continuity is. Let's talk about if a function is differentiable. Okay. So if a function, so differentiable means that we can find the slope everywhere. If a function is differentiable, we can find the slope everywhere. We can draw a tangent line everywhere. There's only 3 cases that we cannot do it. Okay? I'm trying to do the notes go over the 3 cases, or should I just write them down? I'll just write them down. So, it is not differentiable if, first things first, if it's not continuous. If it's not continuous, it's not differentiable. So if there's a hole or a jump, no good. Can't find a tangent. Second one is corner or cusp. A corner, by the way, like that's a corner. You can't draw a tangent line to that because there's an infinite amount of tangent lines. Or a cusp, you want to know the difference, is like when one's a straight line, the other one's like a curve. So, or it could be like 2 curves. So that's a cusp. Again, you cannot find the tangent at that corner or at that cusp. And then the last one is going to be a vertical tangent. So it looks like this. If you get a function that has a vertical tangent like that, it's not differentiable right there. Because let's say that the tangent line is perfectly vertical. So that tangent cannot be vertical. So it's only differentiable if you have nice smooth turns and everything. So let's look at the first examples. This should not take long whatsoever. Let's just rock and roll right through them. First graph right here. This parabola. Is this differentiable? Does it have one of these three things? No, so it's differentiable. So it's differentiable from where to where? From negative infinity to infinity. The second one, is this guy differentiable? Where's it not differentiable at? At 2. So, where is it differentiable? From negative infinity until 2, and then 2 to infinity. 2, 2. Number 5. Is that differentiable? Actually, it says one continuity indifferentiable. It's 2 continuity. So, is it continuous? This line. Yes, it's continuous from where to where? Negative infinity to infinity. Is this thing differentiable? Maybe, yes. It's a line, so it's differentiable from negative infinity to infinity. It's continuous. There's no corners and there's no vertical tangents. What's the slope of this line? Slope is 1, right? So you'd agree that, and it's 1 the entire time? So the derivative is equal to 1? So that's the derivative. It's 1. Number 6. Is this one differentiable? And is it continuous? So it's continuous. I'm just getting lazier now. Indifferentiable from negative infinity to infinity. Is the slope the same all the way throughout? What is the slope? 0. So we agree that f prime of x is equal to 0. So this is me graphing it right here. I'm trying to rush through this because I know you don't want to sit here the entire time. So you'll figure it out as you go, I promise. Number 7, is this one differentiable? Is it continuous? So this is a parabola. Alright, what parabola is this? I have to think really hard now. Who thinks they know what the function this is? Well, it's x squared that's been shifted. It's x squared, or it's x minus 4 squared. So what? It's x squared minus 8x plus 16. Using our shortcut, what's f prime? So at 8, rise and run 2. So the rate of change is constantly changing for the parabola. Is the rate of change of the rate of change constant? Oh, that's a weird question. Is the rate of change of the rate of change constant or variable? It's constant because the rate of change is a line, and the rate of change of a line is constant. So the rate of change of the rate of change is constant. Oh, I love math so much. Seeing all your puzzled looks makes me feel so smart. Like, or a terrible teacher. I don't know which one. There I'll go. You're not a terrible teacher. Okay, number 8. Is this one differentiable and continuous? Well, let's go with this. Is it continuous? Yes, it's continuous from what to what? Infinity to infinity. What about differentiable? Where does it stop at? Okay, so the slope here. So I'm gonna kind of see what differential means just by me drawing on this one. I'm gonna kind of just walk you through how to do this, and then you'll see why. Oh, that's why it's not differentiable, and it makes sense now. So we agree there's two different slopes. Slope to the left. What's the slope of the left? -1, you said? Okay, slope of the left is -1. Until I get to 4. And then what's the slope of the right of 4? It's 1. So this is f of x. This is f prime of x. So if something's not differentiable, what can you say about the continuity of the derivative? It's not continuous. Questions, comments, concerns? Neelish, you understand what's going on?
Absolutely.
Thank you for lying.